vectors, and we use I and J's to represent the horizontal movement. So I represents the horizontal movement, J represents the vertical movement.
So are you a vertical movement then? That was a stupid question.
So I horizontal, J vertical. So let the let U be the vector with the initial point 4, -7, terminal point 2, 9. I want you to first give me the component form vector. So you're gonna, I'll pause it, you do the work. Give me the component form vector.
Which one?
What is it?
-2 on the 16.
Yeah, good job.
-2, 16?
I didn't get that.
Yeah.
No.
No.
That is correct. That is what we call the component form. That means the terminal is at -2, 16. The initial is sitting back at 0, 0. Now it says, write it as a linear combination. Once it's in the component form, it is actually quite easy to just write -2i plus 16j to represent how much are you moving horizontally, how much are you moving vertically. This is not, we're not getting into complex numbers I, but -2i plus 16j. That's all it's asking you when you talk about linear combination of a vector. Combine the horizontal and vertical piece together. Suppose U is 3i plus j and V is 3i minus 9j. They want you to find 3u plus 4v. Now you can work in component form or you can work in the linear combination form. I don't care. Because the coefficients that you're using will be the same in both cases. So with somebody, take U and V, multiply by 3, multiply by 4, and then add those two answers together as fast as you can. I just have, you can work like I said with the I and the J. Go ahead. I just went to component form. So I dropped the I and the J and I wrote down -3, 1. Multiplied both of those by 3 right here. And I got -9 and 3. Drop the I and the J, so I have 3, -9. Multiplied both of them by 4 and I got 12, -36. Now you're supposed to add them together. So when you do that, you're going to take the -9 plus the 12. That'll give me a 3. And then you're taking the 3 and the -36, adding them together, and you get -33.
So you just drop the I and the J.
Now, I wrote down component form. Some of you might have written down they're the same coefficient, so I really don't care what form you write it in when you're in these problems. Okay?
Got it. I understood.
This is that language I'm talking about, direction. Okay? Do not confuse find a unit vector in the direction of the vector I'm giving you, that was 2 or 3 problems ago, with what is the direction of this vector. So when you hear that, what is the direction of this vector, they're asking you to calculate, which way is the compass needle pointing? What angle is it pointing to on your unit circle? And so we've done all the work before, it's really nothing new. You would still draw an XY axis. This is 3 in the horizontal, +3 in the horizontal, +3 in the vertical. So you're going to go 3 to the right, up, 3, right? Well, that's the vector, which is no different than a few chapters ago. That was our terminal side. So we'll drop a vertical altitude back to the x-axis, and theta we're going to put here. So please look right here. Theta is the angle that it makes with a positive x-axis. So they're not talking about, don't give me a reference angle. Start at 0, and wherever the terminal side is, make the calculation. So your answer should be somewhere between 0 and 360 at all times, right? 0 and 360. So 3 to the right and 3 up. Well, what do you really need that formula up there? What are you going to do?
One.
Pythagorean.
Wherever the 18 over 3.
What? I'm not finding the missing side. I'm finding the angle.
Which angle? You could do
Tangent.
Tangent.
Opposite. I mean, it's right there. Folks. Opposite over adjacent. So I'm going to do the tangent. Is opposite over adjacent. Inverse tangent both sides. Most of you can probably do that in your head. In the first quadrant, which angle gives me a tangent of 1?
45.
What?
45.
45 degrees. So when you inverse tangent, you get 45 degrees. So that's the direction that compass needle is pointing at. Check that. You do the next one on your own. Work with somebody sitting near you. You're going 3 to the left. You're going down 4. So you set it up as a tangent of your theta will be -4 over -3. Inverse tangent both sides, I get 53.13. But that's the reference angle. So you have to go all the way from the positive x-axis, all the way around, and you're going to get 233.13. Okay?